Bismillahirrahmanirrahim. Welcome to PMDC Online Lecture Room of Chemistry for Grade 12. Our today's lecture is taken from Chemistry Second Year Textbook, Chapter 13, S and P Block Elements. And our today's lecture is Inert Pair Effect, which is related to Group 4th. The learning outlines of today's lecture are inert pair effect in formation of ionic bonds, inert pair effect in formation of covalent bonds, and finally assignment. So dear students, as we are talking about inert pair effect in group 4th elements. So first of all, we will study the electronic configuration of group 4th elements. The group 4th elements are carbon, silicon, germanium, tin, and lead. And the valence shell electronic configuration of carbon is 2s2, 2p2, silicon 3s2, 3p2, germanium 3d10, 4s2, 4p2, tin 4d10, 5s2, 5p2, and lead 4f14, 5d10, 6s2, 6p2. Here you can see from germanium to lead, D and F electrons are also added. The oxidation states of group 4th elements are normally +4, as these elements belong to group 4th. But germanium, tin, and lead also show +2 oxidation state in addition to +4. So we can say that germanium, tin, and lead show +2 and +4 oxidation state. If we talk about the stability of the two oxidation states in group 4th, stability of +2 oxidation state increases down the group, while stability of +4 oxidation state decreases down the group. And the reason is inert pair effect. So dear students, now we will talk about inert pair effect, that how it affects the stability of cations. So it is the phenomena of electrons remaining paired in valence shell, or it is the reluctance of the s electron of the valence shell to take part in bonding. It occurs due to poor or ineffective shielding of the ns2 electrons of the valence shell by intervening d and f electrons, and it increases down the group. Thus, the lower elements of the group exhibit lower oxidation states. In group 4th, inert pair effect is dominant in lead. And here the reason is greater shielding effect of D and F electrons. As we have seen in the electronic configuration of the group 4th elements, that in lead, D and F electrons are greater. So now we will talk about inert pair effect in lead. Here in the slide, you can see the inner f orbital and the s orbital. And if we talk about shielding effect, the shielding order is that S subshell has more shielding than P, which has more shielding than D, and which has more shielding effect than F. It means that D and F orbitals have poor shielding effect. So, due to poor shielding effect of the F orbitals let nucleus pull the outer electrons. As a result, these valence s electrons are unable to take part in bonding, and this effect is called inert pair effect. So we can say that Pb plus 2 is more stable than Pb plus 4. In the formation of Pb plus 2 ions, Pb will lose the two 6p electrons, but the 6s electrons will be left unchanged, meaning it shows inert pair effect. Therefore, the compounds of Pb plus 2 are ionic in nature. Next, we will talk about inert pair effect and the formation of covalent bond. Here we will take the example of carbon. This is the electronic configuration of carbon 1s2, 2s2, 2p2, which shows that carbon is divalent, but carbon is tetravalent in majority of its compounds. So we can explain this. In ground state, we can see that electronic configuration of carbon is 2s2 and 2p2 and one p orbital is empty. But in the excited state, one s electron is promoted to empty 2pz orbital. So, 4 unpaired electrons are available for bonding, which after hybridization forms tetravalent compounds. You can see here that carbon forms covalent bonds with oxygen. Next, we will talk about nature of M plus 2 and M plus 4 cations. As we know that group 4 elements show plus 2 and plus 4 oxidation states. The nature of M plus 2 and M plus 4 cations can be explained by taking the Fajans rule, in which polarization is a very important phenomena, which says that when a cation approaches an anion, the electron cloud of the anion gets attracted towards the cation and hence gets distorted. The effect is called polarization of the anion. The power of cation to polarize the anion is called its polarizing power. The tendency of anion to get polarized is called its polarizability. Here you can see the polarization of anion by cation. Here in the first you can see that both cation and anions are symmetrical. The size of the cation is smaller as compared to the size of the anion, and hence the charge density on cation is greater. So, cation attracts the electrons of the anion towards itself. As a result, polarization of anion by cation occurs. As the polarization increases, the anion becomes unsymmetrical, and as a result, covalent character gradually increases because it results in the sharing of electrons. So, Fajon's rule states that polarizing power of a cation is directly proportional to charge on cation and inversely proportional to size of cation. Means more polarization, more covalent character. So in this way, we can explain the nature of M plus 2 and M plus 4 cations. So in group 4, Sn plus 4 is smaller than Sn plus 2. So compounds of Sn plus 4 are covalent, while compounds of Sn plus 2 are ionic in nature according to Fajon's rule. So dear students, here are the key points of today's lecture. That inability of NS2 electrons to take part in bonding is called inert pair effect. It is due to poor shielding of D and F electrons. This effect increases down the group. Here there is an assignment for you. You can check out your understanding by trying to answer this assignment. I hope this video will be helpful for you. Take care and thank you.